Good morning, all. Thank you for joining us for today's Long coffee break. I'm Matt Bilsma, sales engineer at Long, and joining us today is Jerry Tybergine from Mass HVAC. Mass HVAC has taken Daikin air handlers and applying engineering technologies to provide custom configurations. By using standard AHU casing, Mass can provide customization, all while saving space at a lower cost than custom AHUs. Jerry, please take it away.
All right. Thank you, Matt. Give me one sec. There we go. Like Matt said, my name is Jerry Tybergine, and I work for Mass HVAC. We provide custom solutions for Daikin and Daikin reps. So we started in 2010. We're located in Minnesota, just a few minutes away from Daikin's factory. When we started the company, we had a vision to take standard air handlers and get you closer to the custom abilities of air handling units. So instead of going full price or a long lead time on a custom unit, we figured that we could take the Daikin Vision Skyline unit, use their software, implement new technologies, and give you more of a custom, crafty layout type unit. So our goal is to design and turn around units very quickly. We focus on really being efficient and in this slower moving custom market. And like Matt said, we implement new technologies in the HVAC field. So whereas a big company like Daikin or another standard competitor might take several years to implement a new technology, we can R&D that in a couple months and be applying it very quickly. So we're always trying to stay ahead of the curve and provide custom solutions for Daikin and Daikin reps. In general, our modifications are trying to always save footprint and trying to increase your capabilities with what you can do with the more complex units like energy recovery type units. So low footprint, high CFM energy recovery. We do that by using the components on the right. So different types of plate heat exchangers, wheels, different types of fan arrays, heaters, wetted evap cooling, and heat pipes. So I'm going to go over a couple different examples of these types of components and show you some cool pictures and CAD drawings. So to start, one of our simplest modifications is a low footprint unit using vertical supply fans. So you can see this unit on the left. Maybe you have a mechanical room that's short on length. We can take a fan, rotate it 90 degrees and put it on top. So you now have an upblast fan. It's not rocket science, but in older days where you're using DWDI fans or maybe still using direct drive plenum fans, that could go up to about 60 inches tall on that top deck. So we're only at about 2 to 3 feet, adding these vertical ECM fans on top. So that saves length and adds a little bit of height. On the right is a compact multi-zone unit. I just like to show this example because while multi-zones are not as popular these days, when you're replacing them, the designs from back in the day, they really got compact, probably invalidated some airflow rules, but we can take QPAC ECM fan arrays, really shrink down the unit, save a lot of footprint. Another example that we like to show off is using this compact economizer layout. So on the left, you have a standard economizer unit with direct drive plenum fans. So you would have return air comes in here and goes through the fan. And then you have your economizer section, which is already pretty compact. This is an angled economizer section. And then you have a supply section. Now on the right is our type of unit. So air comes in the bottom, it goes through this vertical ECM fan and it exhausts out the back, or it can recirculate into the supply airstream. We have outside air hoods on both sides now, so that lets us shorten length even more. And then we use QPAC ECM fans for supply as well. So for this example, we didn't tweak the lengths of any other components other than the fans and the arrangement. So all the coils, filters are all the same. So we saved about 10 feet in length just by going to this configuration. We can do this with indoor or outdoor units. So, if you have an indoor unit, maybe you have a top connection, we can do vertical fans in the downblast orientation as well. Moving on to another example of that compact economizer. This was actually, we did about 7 of these recently, and we're building 8 more of these right now. This is more of a custom layout and a more all-in-one type system. So it's this compact economizer. This specific example is a powered exhaust fan. We can do powered exhaust or return. So you have return air comes in here and exhausts out here, or it can recirculate into the supply airstream. Outside air hoods on both sides. And then this layout had a cooling coil. This could be DX and a gas heater. So a lot of times, you might have more requirements for your rooftop unit, a package system, we can do an air handler that has a very similar layout, but more custom. On this unit, we matched the existing curb, which really helped our customer out a lot, saved on cost. And we did single point power too. This was actually a unitized base, so just one lift. And all the wiring was done internally. It was very clean, and it's a very custom layout, and you're not going for the custom price tag. So just another example of a short footprint unit. And now moving into the energy recovery. Energy recovery units are our forte. We really like to take different types of heat exchangers and increase the capabilities that you can do with them, high CFM or very short footprint. We can go up to 55,000 CFM on indoor, 40,000 on outdoor, and we can do stacked and side-by-side applications. These pictures are plate heat exchangers, sensible or enthalpy. I'm going to go into a lot of CAD drawings now. So these are the pretty pictures. But real quick before I get into that, I do want to go over a concept that we utilize all the time. So on the left is a plate heat exchanger. You've probably seen this before. It's one big diamond, but that limits you because once you get to a certain CFM over like maybe 5,000 up to maybe 10,000 at max, you start to get too long because you just can only increase that diamond size and then you can't ship it anymore. On the right, what we do is we take smaller heat exchanger modules and we stack them in rows. And you can see these sheet metal blank offs right here. It allows you to route the air properly so that the air goes through the heat exchanger. So if you can understand this concept, I'll show you some CAD drawings now. Now on the left is a stacked unit, on the right's a side-by-side unit. Let's focus on the left one first. So this is a partial outside air unit, so you have an economizer. So your outside air comes in here, hits this plate heat exchanger bank, and crosses down into the supply air stream. Return air comes in here, and it exhausts through the core and out through these ECM fans. And there's also a recirc damper because it's partial outside air. One thing, if you take away from this, it really helps you save on height because if you need 500 feet per minute for your cooling coil on the bottom, say this is a 80-inch tall section, on the top, you only have filters. So if we can angle those, you can shrink this height down to about 40 inches. So a wheel being in, a square would force you to have 80 on the bottom and potentially 80 on top. So this saves about 4 feet in height. On the right, side-by-side unit, outside air comes in here, crosses over, supplies out. Return air comes in here, crosses over, and exhausts out here. So just another example showing how we can vary the aspect ratios as we go. So you have more width over here, less width over here because you don't really have any high CF or high face velocity components. So side-by-side and stacked arrangements, indoor and outdoor. Now, wheels, you probably are a little more familiar with wheels. These are energy recovery wheels. We can really stretch the capability of what's in a standard manufacturer's software. I would say standard manufacturers typically max out at about 15, maybe 20,000 CFM. We can take that up to about 35,000 on outdoor and 50,000 on indoor. So if you think you have to go custom just because you have higher CFM, you can probably do this with Daikin. So outside air comes in here and then goes straight through, supplies out. Return air comes in here and goes through the wheel and exhausts out. And this is an outdoor unit. We added a lot of bells and whistles to this one, a lot of different lights and single point power to this as well. So a very clean solution. I believe this was a 32,000 CFM, 100% outside air unit. And on the right is a 45,000 CFM indoor unit. So when we get to really high CFMs on indoor, we can do 2 wheels side by side in a stacked configuration. So outside air comes in here and goes through these supply fans. And on the bottom deck, you have return air comes in here, goes through the wheel or bypasses and goes through the exhaust. So like I said, takeaway from wheels, if you think you have to go custom just because you're at a higher CFM, you can go with Daikin. And this is actually, I'm wrapping it up here. This is a concept that we are really excited about. It's called the Reconomizer. So I don't know if you've ever run into an issue where you have high CFM on supply, say 30,000, and you only need about 25%, 20% outside air, but you still need energy recovery. Well, if you were to go with the traditional stacked or side-by-side arrangements, you're really hurting on footprint because you have to take that full CFM and split it because you still need economizer. So what we did was we decided, let's put a smaller wheel or plate heat exchanger in the economizer section, because you only need to be able to do 20 to 25% OA. So this is a return fan, and it goes through the wheel here and exhausts out up top. Outside air comes in from the top, goes through this filter bank and through the wheel, and then in the supply air stream. And then you have a recirculation damper too. On the bottom, that's normal operation, by the way. On the bottom is economizer mode. You just shut these two dampers, so now you're not going through the wheel at all. And then you exhaust out here, and you bring in outside air here, and you're not recirculating anymore. And then last slide, this is the economizer concept with enthalpy plates or sensible plates. This is an outdoor unit. So you have return air comes in the bottom, goes through this fan array, and then it can either go through the heat exchanger and exhaust out, and then minimum outside air is pulled in through this hood. It goes through the heat exchanger into the supply air stream. And then you also have a recirculation damper too, so the return air can go straight through. This is normal operation. On the economizer operation, you close all these dampers right here. You open up these. So now you have exhaust going directly down and outside air pulling directly through here. So like I said, this could go up to about 40,000 CFM on supply, where you might only have 8,000 of outside air that needs heat exchange. This really minimizes the footprint increase and is a really unique layout. And that's all I got for you. Matt, I'll let you take it here.
All right, thank you, Jerry. Appreciate your time today and introducing us to a few AHU configurations. The great part about this is that we can see that the value that's being brought to the market in the fact that we're using standard casing and a lot of standard components and just rethinking what's going on inside of that. And so we appreciate that. As always, if you have questions or opportunities to apply this technology to your projects, please contact your Long sales engineer. Now for this week's winner, you can pick from 3 gifts, either a $100 melting pot gift card, an outdoor rocking chair, or the Magnum PI Funko Pop figure. Please join us for next week's coffee break as Bobby Henderson leads the presentation on Thermocore underground piping systems. Thank you again for joining us. We appreciate your time.